And the last problem you've been given, it's got that funny symbol in it again, but I was saying earlier on that it's just an old notation for the universal set here. So let U, the universal set, we'll call it, let be all the numbers x where they used to use a colon, we now use a vertical line. So I'll change this to a U, so it's a bit more familiar. So U is x where 1 is in between x or equal to x and 17. So that means that x could equal 1, but it could not equal 17. And we're also told that x is an element of the natural numbers. So we're not dealing with all of the numbers, only the natural numbers that begin at 1 and finish just before 17. So part A, I, says list the elements of this curly E, we'll call it a universal set. And so we know that we're starting at 1 and going all the way up to just before 17, or the natural number just before that is 16. So 1, 2, 3, 4, 5, 6, 7. And you might be thinking as I write this, would I be allowed to write 1, 2, 3, ... 16? And really, look, this is only taking me a few more seconds. Why take the chances that a mean examiner is going to take off marks? Just write them all down. Of course, if it was something like 40 or 50 that you had to write, clearly IB is not expecting you to put in 5 minutes of your time listing a set of that size. But it didn't take me long to write down just those 16 elements. Okay, the question at the top went on and said P, Q, and R are the subsets of our universal set, such that P represents all the multiples of 4, Q represents all the factors of 36, and R represents all the square numbers. And remember that we're only looking for numbers that fit one of these three conditions for the three sets inside our universal set, within the numbers 1 through 16, and those are the only numbers that we will consider. Why don't we first figure out what P is? So I don't really have room for it here, so I'm going to do it on this side if you don't mind. So we're going to go all of the multiples of 4, and so smallest multiple of 4 in the universe is 4, and then we've got 8, and 12, and 16. Those are all of the 4 multiples of 4 within our universal set. Q are the factors of 36. By factors, we're saying something that can be divided in evenly without any remainder. And so, let's see, we'll start with, well, 1 can divide into 36 perfectly. It goes in 36 times. Or you could say, maybe, another way of thinking of this is 36 divided by 1 equals a whole number, 36, that is to say no remainder. So 1 must be a factor. What about 2? 36 divided by 2? Yes, that's a whole number. So 2 is a factor. 36 divided by 3, that equals 12, so that's a whole number. 36 divided by 4, that's 9, so 4 must be a factor. 36 divided by 5, that would give me 7.2. And because it's not an integer or a whole number, then we will not include 5 as a factor. 36 divided by 6, that equals 6. That's 6 must be a factor. 36 divided by 7, that's 5 point something, 5.14. So that's not going to be a factor because of the remainder. Hope I said 7.2 times back here for 5. 36 won't divide 8 evenly. 36 does divide 9 evenly. So 9 is in there. 36 divided by 10, no. 11, no. 12, yes. So 12 is a factor. Let me just clear a little bit more space for myself as I add the element 12. And I think that's it, because 13, 14, 15, and 16, none of those 4 final numbers divide into 36 evenly. And the square numbers between 1 and 16 are simply 1, 4, 9, and 16. Square numbers, by the way, are numbers like 1 squared, 2 squared, 3 squared, 4 squared, etc. And of course that's as far as we're going to go, because 5 squared equals 25, and that's beyond our universal set. So we'll only go 1 through 4, and you'll see I've listed them over on the left side. Okay, we're finally ready to move on to part II. We're looking for the elements of P and Q and R, that is to say numbers that exist in all three of these sets simultaneously. So let's have a look. Well, we can see that 4 occurs in all three sets. How about 8? Nope, doesn't appear in either of the others. How about 12? We see it here, but it's not down here. And how about 16? No, it's not in the second one, even though it's in the third. We're looking for numbers that appear in all three sets simultaneously. And so that's it. We got nothing other than the 4, and I can just close my set right now, because that's the only element that belongs to each of them. Part B, describe in words the set P union Q. We would say P or Q. So P represents the multiples of 4, Q represents the factors of 36, and so this set it is the set of all, I guess maybe I should make a quick reference to the universal set. So we're looking for all natural numbers from 1 to 16 inclusive. It's the set of all natural numbers from 1 to 16 inclusive. And I say inclusive just to indicate that 1 and 16 are included. You remember 17 was not. That must mean 16 is the biggest number. So all natural numbers from 1 to 16 inclusive, and now we want them to abide by this condition. So we want them to be P, we want them to be a multiple of 4, or we want them to be a factor of 36, or both, right? So it is the set of all natural numbers from 1 to 16 inclusive. Maybe I'll change maybe I'll just say that are, because I've already said all the numbers. All the natural numbers that are multiples of 4 or factors of 36 or both. And now part C, we need to draw a Venn diagram to show the relationship between sets P, Q, and R. It might be worth just quickly seeing whether we do indeed have an overlap between each pair of these sets. I can see that P and Q have got an overlap of, 12 appears in both. I can see that P and R have an overlap because 16 appears in both. And I can see that Q and R have got an overlap because 9 appears in both. So it's safe to say that all three of the circles do overlap one another. Now, just to make sure that things are plenty big enough, I'm going to draw my circles first. And now I can draw my box around the outside. And that's my universal set that we are denoting with a capital U. We'll label the 3 circles. Very important that we label the 3 circles and the rectangle on the Venn diagram. And now we need to demonstrate, I suppose, well, that is the relationship. We're now on to part I. Write the elements of our universal set in the appropriate places on the Venn diagram. Alright, I might have to scroll up just to have a look at what my sets are. So P is 4, 8, 12, 16. You notice that 4 appears in all 3 sets at once. So let's put the 4 right in the middle. And I also need to distribute 8, which does not appear in either of the other 2 sets, so it must be alone in this region. 12, which also appears in Q, so it can be in the overlapping section between P and Q. And 16, which also appears in R, and so it must go in the overlapping section between P and R. I've now placed my 4 elements of P. Let's place the remaining elements of Q. So far I've placed the 4 and the 12. I still need to put the others. So my 1, which also appears in the R, so that's in here. 2 appears only in set Q, not in the others. Again, 3 appears only in set Q. 4 we've already included in the middle. 6, which we haven't written yet, and that appears only inside Q. 9, which is which also appears in set R, so it's in this overlapping region. I've got a 1 and a 9 in that area. And lastly, 12, which I've already written in the overlapping section between P and Q. And lastly, I just have to put the elements of R. 1 I've already written, 4 I've already written, 9 I've already written, and 16 I've already written. And so I don't have to write anything in that empty space. And I am, I'm actually not quite finished, because there's other elements of the universal set that haven't yet been represented. So far I've got 1, 2, 3, 4. Where's 5? It doesn't appear anywhere. It's not in any of the 3 sets. 6, 7, again, not in any of the 3 sets. 8 we can see, 9 we can see, 10 does not appear in any of the sets, neither does 11. 12 I can see, 13, 14, and 15 do not appear anywhere, and so those can also go on the outside, 13, 14, and 15. And a couple of you might be looking at this Venn diagram thinking, well, if we've got this empty region, would it have been possible to draw this any differently? And just thinking about that, I suppose this whole region here is kind of, because it's empty, it's sort of useless. So I suppose maybe if you had drawn R like this peculiar shape, such that this empty section doesn't even exist, that would have been fine as well, but I'd be certainly not going to have a problem with you doing it like this. So there we go, we're finished. Now I just want to have a look at the solutions. So we'll just scroll through quickly the actual IB solutions here. And so there we got number 1A was 11, that's right. 5 that were in these 2 sections together. And 8, 4, 6, and 4 gave us a total of 22. Great. Remembering the 4 that was on the outside, right? And you'll see it's 1 mark for each correct answer. And also in part B, it's 1 mark for correctly shading the region that is not in G, but is in S. Number 2, notice that you get 1 mark for drawing a rectangle containing 3 intersecting circles. If you did not draw the rectangle, you would not get that mark. Part B, we're now going to fill in the different numbers, and that's exactly what we got. You'll notice that we have a total of 3 people who play cricket and basketball. Only one of them does just those 2 things. The other 2 happen to be swimmers. So we have to employ some subtraction and not assume that some things mean only when they don't explicitly say only. You'll see that you would get 3 marks if 6 or 7 correct numbers have been put into the regions. If you only got 4 or 5 correct numbers, that's 2 marks. 2 or 3 correct, you would get 1 mark, and if you only got 1 correct number or 0 correct numbers, of course you would score 0 in part B. Part C, if we add up all of the numbers that we've got so far, we get 25. We'll subtract it from the total number of numbers, and we see that we get 5. Now, if you showed this method, you're guaranteed a mark, even if you get the wrong answer. If you want to take the risky way and just sort of write down the answer, you will get a full 2 marks, except that if you made a mistake, of course you would get 0. So better to show your work and guarantee yourself pot marks. Here's number 3. We can see that we've got X in between drama and sports. 48 minus X on this side, 44 minus X on this side. And remember that there was 0 on the outside. They didn't bother to write that down, so I suppose it's implied that there's 0 there. And look, if we sum these 3 regions together, knowing that we have a total of 60 members in the club, we can deduce that X is equal to 32. And yeah, the set of members who did not attend both drama and sports. And you can see the marks on the right. 3 marks for the Venn diagram, 1 mark for the method, and 1 mark for coming up with the value of X, and then 2 marks for the statement. And lastly, number 4, the universal set 1 through 16. P and Q and R, the only overlapping element is 4. P or Q, we can say, is the set of numbers that are either multiples of 4 or factors of 36, or both, that is to say everything that is in P or Q. Here's our Venn diagram. They've put commas in between the different repeating elements, and I just sort of wrote them in random places around the diagram. Both are fine. And so you can see the way that marks have been distributed. 1 mark for each of the sets in part A, 1 mark for the statement in part B, and 2 marks for the diagram and 3 marks for the numbers in part C.